else, those they are required. So say for example, a very simple example, we can take the physically challenging people. So objective is that how we can make the space suitable for physically challenging people. So and especially needful people's how we can make them. So we finished some of the thesis in this domain recently, and we figure out, yes, the sensors or these machine learning can make the easy life for those they are required, especially for physically challenging kids, childs, and other things. Then we can also make them for security and privacy purpose. So it's a wonderful time for this one. And why this is so, that means burning topic or so hot topic right now, smart space, smart sensing and other things. Multiple reasons are there. Number one is that the low cost sensors. So right now the sensor cost is very less as compared to earlier one. So the cost is the important factor right now, that why people are so energetic to use the smart space, to use the sensor, because of the low cost. And they can easily purchase, they can easily use, they can easily that means deploy or develop the solutions because of the cost. Another reason is the fast communication. Earlier, the communication is a challenge. That means very few people they have internet connections. Right now, everywhere is the internet. Even free Wi-Fi is available everywhere. Almost all these smart spaces. So availability of the Wi-Fi, availability of the internet makes them faster, and sharing the information is very easy. When you have the information, you can take the decision. You can make all these things. So this is the reason why the smart space is right now the burning topic, and people's focus on smart space, how we can. And the third and the important reason is the availability of the resources. So that means we can say that means 2005, 2010, very few that means reports are available, few videos are there, few study materials are available for machine learning and other things. Right now, this is open source access and everything. So people can easily learn, easily implement, easily use. Even open source data set is available. A huge data set is available for open source for training the model, testing the model, and all other things. So all these things together, when hardware cost is very less, communication is availability is very high, communication cost is less, availability of the communication is very high, and third one is that the software or the data set or the tools for learning is available. So all these three together, it is very easy to make or convert a space into the smart space based on the user's demand, whatever demand is there. So that is there, and here in this that means talk, we try to cover up that how we are using this smart sensing or machine learning and to make the space into the smart space. So before we start discussing, this is a very basic, very basic talk is here. So this is only for the discussion purpose, not other purpose that we discuss what we are doing. So if you have any suggestion, points, comment, definitely you can ask at the same time. We will discuss and try to sort out in that case. So before we start, I want to know that if any one person is working on a smart space, can you please share your experience, or if you have done something in IoT or sensors or something else, if anyone want to share their experience, then that will be very helpful for a starting point of view and also for making this. So can anyone participant can voluntarily start? Yeah, please. If anyone is using sensors or IoT concept in their day-to-day life, or they have developed or built some solutions in their institute for any purpose, so if anyone has any experience, they are always welcome that they can share their experience right now, that we have done this, that, or what challenges they face, or how they are using or they are deploying. So anyone voluntarily want to share your experience? Okay, perfect. So let's start our talk, and we will see later on one by one. So in this talk, this is a very basic talk about IoT, machine learning, how to use ML in IoT to convert a space into the smart space. And we will cover some examples or the deployment scenario that we have done at IIT BHU Varanasi or in our research portion. So I think so the slides are perfectly visual, and if you have any point, you can ask at the same time. So very first question, that before smart space, IoT comes into the picture. So that means IoT is nothing to be new. So we are not going in a much deeper. But yes, so for the starting point of view, we need to make an environment for that one. So IoT. So what is the IoT? A question comes into the picture. So this icon is a very good example of an IoT. So you have seen that some are the solid circles, some are the empty circles are there, and one black box like cloud is there. So it indicates multiple things. The one thing is that connectivity. So all assume that 1, 2, 3, 4. I just zoom it. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. 8 devices are there, and all these 8 devices are connected with each other. That is the first principle of IoT. Connectivity is required. And via internet or others, connectivity is required. So all these 8 devices are connected with each other. Some machines are the solid, some machines are the empty. That means they have the heterogeneity. Heterogeneity indicates that they are not the same type. Now, the heterogeneity definition is different based on the resources. So, say for example, in terms of the processing power. So this device is has the high processing power as compared to that one device. A huge resources is there with this device. Say for example, this device has some GPUs, but there is no GPU. Or this device is the laptop or a system, this is a smartphone. So processing power is less as compared to that one. So it indicates that the devices are heterogeneous. That means they have the unequal resources. Or they may have the unequal resources. Always it is not true, but yes. An IoT definition says that the devices are connected with each other and the devices may not be the same type, same resources. So processing is a one resource. Other resources are also possible. Say for example, memory storage. Some one machine has the 1 TB, other one has only the 200 GB. Like this one. So that is also another resource. So whenever we see the different of icons of the devices, which indicates that the devices are not the same type. So this is a very well that means picture of IoT. We need to that means carefully visualize this one. And all devices are connected or interconnect with each other, which is like the black box here. We don't know about how this device can connect with this one, but they have some connectivity. We have. Now another indication of this picture is the connection from one device to that one environment. Some devices are so close, some devices are so far, and the communication also a different type. Okay, IoT node says that this is the wired or wireless. Okay, that is the another class of that means that is another class of communication or discussion that okay whether this is the wired or this is the wireless or whatever is there. So IoT says that the devices are connected. Devices are connected wired or wireless. It depends on the scenario. It depends on your application, or it depends on the demand of the environment. So say for example, when some river is there, when some mountains are there, that type of area is there, that wired connection is a very challenge problem. So in that case, the wireless is the suitable. But when you talk about the inside the campus where high bandwidth is required, dedicated connection is required, strong connection is required, then wired connection is better than the wireless connection. But connection is there. So IoT assume that devices are connected and they somehow hide the information about the connectivity. That means they are wired connection or wireless connection. Depends on the availability, depends on the scenario, depends on the environmental requirement. But connection is there. Devices has the processing power. Devices has some sort of the resources, and that resources depend on the environment conditions and other things. So, but yes, this is not a constant that all the devices are the same type in IoT. Otherwise, what's happened that if we demand the same type of the IoT, in that case, devices that means the IoT is not goes in a large scale. If we are assuming that IoT in a large scale that covers the entire campus, entire city, then definitely we need to assume that the devices are heterogeneous. Heterogeneity properties, they are unequal in terms of processing, in terms of storage, in terms of their security challenges and all other things. So this is the complete IoT definition. Devices are connected. Devices may not be equal. The connectivity of the devices are different types. That means wired or wireless. Data bandwidth is a different type. Heterogeneity, not only in terms of processing, but also in terms of storage, but also in terms of security, but also in terms of their throughput and other things. So now if we assume that the IoT is complete, this is the IoT definition. So the next question comes into the mind that where we use the IoT in our campus or IoT in our smart environment. Yes, we have multiple applications of IoT. Your RFID tag attendance system itself is an example of the IoT. Most of these universities and colleges right now, they are using the attendance system is the based on RFID. That is the example of the IoT. They collect the information, they process the information, they transfer the information, they enter the information, they secure the information and save the information, and finally take the decision. Based on the decision, they share this decision to the competitive authority that what is their attendance. So this is an example of the IoT. So IoT is everywhere. In day-to-day life, we use the IoT, we use huge IoT applications in our life. Now, when we open the IoT, that okay, if we say that okay, heterogeneous devices are there, but what is the devices in IoT? So usually IoT assume that the smart devices, not the dummy devices. Dummy devices means they are not capable to do processing, they are not able to take the decision, they are completely dummy device. They have no power, nothing is there. Example of that. Now IoT assume that they are connected the smart devices surrounding in that environment. Smartphone is the best one example of that one. Why smartphone is an IoT device? Because they have the processing, they can do something, they can connect it, they can share the data, all these things are there. So if you take an example of smartphone, the smart camera is there in that smartphone. So smart camera, they capture the image, they process the image, they generate the result and share the result to someone else. So capture the image, face recognize, and understand that who else is there, and after that generate the image, capture the image, extract the information, they transfer this information to the end user. So IoT assume that the devices are capability of the smartness. They are the smart devices, they can collect, they can share, they can store the data and other things. And yes, IoT also assume that Acosta, that means they do something based on the result. So say for example, they capture the image, recognize the face, find out who else is there, that means the name of that person, and display the name of the person on that screen and transfer this information to the base station. That means they do something based on that one. Okay, they capture multiple images, merge together and generate the result like this one. That is also an example. So IoT doesn't say that only send the information, nothing can do. No, IoT also assumes that based on the result, based on the information, whatever the information they have collected, they do something on that one. Another example is that means fire detection system. That is the example of IoT. You have some fire sensors are there, and they detect the temperature. Based on the temperature, if more than the threshold value, if multiple sensors simultaneously detect the temperature is high, they generate the alarm, they switch on the pump and other things are there. So that means they have some response is there. So that's where the IoT has numerous of applications. If they collect the information, then the application are a little bit less. That means what we will do the information. We need to take some action. Action is also the part of, or reaction is also, response is also the part of that IoT. So IoT also have the connectivity between the response device to the desired location and other thing. This is a complete example of IoT. So if we start see this example from what this person is doing, so I just zoom in. So I assume that there is one environment is there, and we convert this environment into the smart space, a smart environment with the help of sensors or with the help of this IoT concept like this one. So very first step, when room is there, some smart devices are there, some camera is there, some RFID is there, some light lamp is there, some AC is there. All these are the equipment inside the room, and they are connected with each other. That means they can share the information, they can generate the command, they can share the commands, and all other things are there. And when one person is enter inside the room, very first step, when a person is enter inside the room, they have some smartphone or they have some RFID tag. Okay, very simplicity point of view, we have assumed that they have the smartphone, and the smartphone Bluetooth is on. So when the Bluetooth is on the smartphone, one Bluetooth reader is there connected with this device, they capture the information of the user. That means Bluetooth is smartphone ID. So they capture this unique ID and transmit this ID to the base station to recognize that whether this Bluetooth ID is registered or not. So assume that this Bluetooth ID is registered to that center. So Bluetooth device is there. A smartphone, they have the Bluetooth communication protocol, and Bluetooth device is there. So this center device, they receive the Bluetooth signals, and in that signal, they have the Bluetooth ID. They transmit this information to the base station. Base station check that whether this person is registered or not. Assume that this person is registered. So on the display screen, they display the name of that person first. So hello, like this one. So they display the name of the person. How they display the name of the person? They collect the ID of the user and match this ID to the base station. And base station says that yes, this is a registered user. Their name is this one. So very first thing IoT will do, they display the name of the user. Once they display the name of the user, user experience is very rich. That means they feel that yes, so that's very, that means interesting, welcome. Whenever I'm coming, they say that hello, this one. So the experience is very rich. Now the second step is that since this user is already registered, that's why their name will be displayed on the screen. Then what system will do? System adjusts the light intensity and the temperature of the room based on the user's demand. So say for example, I like this level of the light intensity. I'm not interested in very dark brightness of the light inside the room, and I'm also not interested in darkness in the room. So that type of light intensity I always prefer. So they automatically adjust the light intensity based on the user's preferences or whatever the data set user already feed on the server. That they say that okay, I want this level of the light intensity, and I also prefer the temperature. So I usually prefer the temperature of, assume the 28-degree temperature. Someone wants 22 degrees, someone wants 34 degrees. So that information is already on the server that this user X Bluetooth ID is this one. The second column is their name. The third column is their light intensity. The fourth column is their desired temperature. So in that case, this is a complete example of the IoT. Very first, IoT has the communication and the connection between the users and the base station via this device using the Bluetooth or some sort of things. Second is that based on the connection, based on the collected information, they generate the result in terms of their name, whatever the name display on the screen. The third contribution is that once they display the name, they have the information, they set the light intensity, they also set the room temperature. So all together we can say is the example of a smart home using the IoT, using the sensors. So here internet comes into the picture that for collecting the information and for sorting the information. So we can say this is the example of IoT. Yes. So any question or any suggestion, or have you any example of the IoT that you have used in your campus or similar to that one example you have in your mind? So can you please share? Anyone participant can share this one so that we can discuss that scenario also, that how we can improve the scenario or what is the IoT there. Anyone participant want to share their scenario here? So anyone participant, they use in their institute the smart attendance system sort of thing, or all you have to use the manual attendance. Say for example, you use the RFID, some solution is there, anyone institute?
Yes, sir, we are using RFID in library section.
Libraries. So can you just give the complete scenario that how you use the RFID and what is the benefit of that one?
Whichever available in the library was registered, and each student is having their own ID card. During the entrance, they has to swipe through the RFID scanner, so that whichever book they are accessing, that is automatically registered in the server. Within the room, there is also one RFID reader present where they need to register the books which they are issuing.
Yes, and so this is thank you very much for sharing your scenario here. Yes, that is the application of the IoT sort of thing, that RFID based the student login sort of things, that who else is the student or the student detail is there, so that in that case manually entry of the student is not required. So that means man-made errors are not there, as well as we can save the time. In that scenario, what I assume that along with the RFID, you also have the QR code or barcode on the book. So I think so. Barcode reader or QR code is also required in that scenario.
Yes, yes.
Yes.
Sir, I am thinking about one point that
yes.
Process can be defined so that
Okay, so I think some
such as washroom. So how they are actually, what is the situation? Whether some form of, whether they are actually at good condition or not. Whether such a situation can be identified without using some form of sensor or some form of IoT-based device.
Hello. Yes. So some voice is breaking. I'm not able to complete. Can you please repeat once again?
Sir, I'm thinking about that a situation that elderly persons are present in some suspicious area, such as their bedroom or washroom, and whether they are actually present in a good condition or not. Because we cannot set some form of sensors within those areas, and even some IoT devices cannot be installed. So some form of situation where we can identify what is the actual position, whether they are in good condition or they are present at some difficult situation.
Yeah. So the first thing is that that means when you monitor the human activities, especially for elderly case or some kids are there, so inside the home or inside the environment, camera is not possible because of the privacy issues or because of the comfort of the end user. So camera is anyhow it is not possible, but based on the sensor it is possible, because the sensor is a passive device sort of thing. They are not have the visualization and other thing. So sudden fall is there, they easily can detect with the help of the sensors. Now the sensor is also, it's a very interesting that question, that how we can detect the that means take care about the elderly peoples, especially for disabled or those they have some health issues. So in that case the camera based solution is anyhow not useful, and no one can use the camera based solution because of the privacy of the end user. The second solution is the other solution is only that the sensor based. So sensor is a good approach in that case. Sensors can detect the sudden fall with the help of IR sensor, with the help of human activity sensors. They can detect the sudden fall very easily. Now sensor based solution in IoT also classified into two categories. One is the sensors, variable sensors. Other one is the environmental sensors. Variable sensors, say for example, a smartwatch is the variable sensors. So a patient or elderly people, they variable, they vary that sensors, such as a smartwatch. They have the sensor, they can detect the sudden fall like this one. Another class is that that is the environmental sensors, because since we talk about the elderly peoples, those they have 75 plus year age, and it is very tough right now. We use variable sensors to them. They are not very comfortable with that one, and as well as in the same case as the kids or that babies are there. So variable sensors are not suitable in that case because of their discomfort, wearing of all these sensors in always. So they are bathing, but they need to wear the sensor. It is not possible. So in that case, the another last class is that the environmental sensors. So if we set up some environmental setup in washroom like this one, where a sudden fall is there or not while they are bathing, or in a bedroom, because the sensor says no camera, so we are not worried about all these things, privacy and other things. So but the sensor can successfully detect whether the sudden fall is there or not. So the third and the important class is the environmental sensor. So you can paste some sensor nearby the washroom walls, nearby the bed and other things. They can easily detect the sudden fall. Finally, after all these exercise, the camera based, that is not possible because of the privacy. The second one is the variable sensor, that is also feel discomfort after a certain age, because that means right now they are 70, 80 years age, and at that time they have not used any variable sensors in their entire life, so not possible. And the third one category is the sensor placed nearby the bed, nearby the walls or bathrooms or washroom, like this one, that is the third class. But the third class also has huge cost. The sensor is not so much cheap what we are talking, and the maintenance of the sensor is also costly. That means changes the battery and other things are also time consuming and also not very frequently. So say for example, if you have one elderly people in your home, their health issues are there, and so we need to take care about the old age person, and also we need to replace the batteries or the maintenance of the sensor. That is a very hectic job in that case, because we are required the multiple sensors. If you want to cover the washroom, if you want to cover one bedroom, one hall is there, one kitchen is there, if you want to cover all these 4 elements, still you need around 20-25 sensors as required to this entire environment. So the replacement of the battery, replacement of the sensor, maintenance of the sensor is also a challenging task. So right now people are working on CSI, that means channel state information. So that is the Wi-Fi based approach. So that is currently, that means burning topic is going on. So one Wi-Fi sender is there, multiple Wi-Fi receivers are there. So between the sender and receiver, whatever the activity person is doing, they can detect based on the changes of the states. So if one person is sleeping, the Wi-Fi channel state is different. If one person is walking, one person is sudden fall, one person is eating, like this one. So that is interesting topic of the activity recognized using the channel state information, CSI information of the Wi-Fi. So one Wi-Fi sender is there, one Wi-Fi receiver is there. In between whatever the user is doing, we can detect the activity of the user. Of course, the accuracy is not as good as the sensor, and the accuracy is not as good as the camera based. Camera is the best one accuracy. The second accuracy is the variable sensor. Third accuracy or the low accuracy is the environmental sensor, and fourth one least accuracy in the Wi-Fi channel state, like this one. But here the cost is very less, only one sender is required. Most of the case 1 or 2 receivers are required. Sender is simple, Wi-Fi chip is there where cost is around 300 rupees. Wi-Fi receiver is also 200, 300 rupees. So entire solution you can make in 800, 1000 rupees. And battery replacement is also not required because the power consumption is very, very less in that case. So this is the way that how the IoT makes the scenarios, and we can take care about this thing. So this is the way a good solution, a low cost solution we can propose, especially for elderly or patient person or the monitor, child care monitor and other things. So I hope so that you got the answer that how we can make the system using IoT for elderly.
Yes, sir.
Hello, so we continue.
Sir, how to integrate the machine learning so that optimized result can be produced? So where to apply this machine learning algorithm?
So
because at the sensor level, machine learning algorithm cannot be implemented, I think.
So there are machine learning, that means if you search on the machine learning, there are 2 types of the machine learning approaches. One is of course the server based. There huge resources are required. Some GPUs are required because of the complex RNN CNN architecture. Very big architecture is there. Numbers of operations are required. Another class of the machine learning is the tiny ML, tiny machine learning. The size of such machine learning models are very small. They have a limited resources. They have the limited layers are there that can easily deploy with the nodes or inside the node. So I can take an example of ESP32 cam model is there. ESP32 camera model is there, and their cost is around 400 rupees right now. They have one camera, they have a Wi-Fi, they have the Bluetooth, and they also have a one controller. That means all 4 elements are there: Wi-Fi, Bluetooth, camera, and controller. Entire cost is 400 rupees. Their controller is sufficient to solve a small size of the problem, a tiny machine learning problem. That means, say for example, linear regression, logistic regression, or CNN architecture up to certain levels or layers. So that level of capacity and capabilities are there, and that is more than sufficient for such sudden fall detection and other things. So these sensor are not the sensor. These are the nodes. When we say the sensor keyword, sensor indicate only one physical device they can sense. They have the sensor equipment. When we talk about the sensor nodes, that means they have the sensor, they have the communication, they have the processing unit. So these ESP32 CAM models type edge devices, which are very small in size, a tiny controller is there. They can easily solve the tiny machine learning problem. The size of the machine learning problem is very small, and you are not required the result in a very high precision and high accuracy. If you are expecting the result is almost 100% accuracy, then definitely we need to think about the server-side machine learning and high-end machine learning solutions. Here, the limited machine learning solutions are sufficient for that one purpose. So I think so that you got the answer that where we can solve the problem. So first level of the problem you can solve on the node itself using the limited controller, limited processing. If you want more good accuracy, if you want higher accuracy, more good results, more applications, then definitely you need to forward your information, you need to forward your data set to the server side, and the server has the huge processing, huge storage capacity, then definitely they can solve the problem in a much more interesting fashion. So I think so you got the answer. And so any other point, any other participant want to add in this direction or have some experience? So anyone used the tiny machine learning in their research purpose or in their teaching purpose, tiny ML, not the normal machine learning, a large scale machine learning. Yes, so my suggestion is that please, after this course, just go through on the internet and find out that what tiny machine learning is exist and how we can use, what is the applications of that one. So numbers of tutorials are there. Right now, the future is the tiny machine learning, not the normal machine learning. Why? Because of people are not interested to share their data. So for example, social media, right now people are, that means not interested to put their data on that social media groups and other things only because of their privacy and other things. The tiny machine learning says that we will solve the problem in your smartphone. We are not required to communicate your data to the server and do all these things. So whatever your data is there, we can solve your problem in your smartphone. So say for example, text to speech. So earlier the solution is only the server side text to speech. Right now, some models are coming that they can give a limited accuracy text to speech on your smartphone. So whatever you are saying that whatever your text is there, they can automatically convert in the smartphone. So advantage is that the data sharing is not required. That means you make your privacy at your end device, and also not communication is required. So you are not required to communicate your data to the server side. So if you are not required to communicate your data to the server side, numbers of that means you can solve the challenge such as privacy, security, energy consumption, multiple in-between devices for communicate your data and other things. So tiny ML is the future, and numbers of devices are there. They support the tiny ML. So please, after this complete course, my suggestion is that to go to the tiny machine learning, how you can use in that case. So let's continue our talk is here. So now after this scenario of the IoT scenario that we have seen right now, that one person is entered inside the room, and you can see the name of the person on the screen. And based on the data set, the light lamp automatically adjusts their light intensity, as well as the that AC automatically change the temperature based on the user's demand. Now, after that, what components are used in this entire scenario? So we have seen that the sensors are required. Otherwise, how we can sense the user's presence? So we need some sensors. They can sense the user, that user is enter inside the room, and that means they can collect the information like this one. So sensor technology is required. So whenever we talk about the IoT, in that case, the main component is the sensor. Sensor is required. They can sense the environment. They can sense the person presence and all other things. So anyhow, sensor is required. Sensor technology is required. The second one is the communication. Without communication, how we can collect the information, how we can transmit the information, how we can generate the result. After the result, how we can trigger the lamp or the AC and other things. So communication is everywhere in the IoT. Communication is required. So one portion is the sensing. You need to sense the environment. The second is the communication. You need to have some communication capabilities. Of course, sometimes we assume that high bandwidth communication. Sometimes we assume that the limited communication bandwidth is more than sufficient for our application. So communication, but anyhow communication is required. Third one is the intelligence is required. And intelligence, right now I have used the machine learning keyword because of right now machine learning is going on, and our focus is on the machine learning. Otherwise, machine learning is not only the intelligence, multiple solutions are there for the intelligence. Machine learning right now comes into the picture, but people are using the intelligence in earlier days also. The artificial intelligence, one very known book is published in 1980s, where numbers of approaches are there, A-star algorithms and other things are there. So right now the machine learning is going on. That's where we talk about the machine learning as of now. So the machine learning, not the correct way. Here we need to write the intelligence, and machine learning is a subdomain of that intelligence. Can anyone can suggest any other name of the intelligence, not the machine learning, deep learning? How we can add the intelligence in the system? Anyone please suggest that apart from the machine learning or deep learning, any other way that how we can add the intelligence in the system? So I think so you heard about that means hidden Markovian model, some signal processing approaches. So these are also the intelligence way. That means they can also make the decision. They can also do something based on some current state or based on some previous data like this one. So just say for example, hidden Markovian model is the one example. They collect the information from the users. They do all these things and find out and generate the result. That is also an example of the intelligence here. They have the decision capability, correct decision capability. And signal processing, numbers of algorithms are there. Say for example, filters are there. So you are not required every time the machine learning make the filters. You can use Kalman filters and other things for filtering the data set. So you're not required the machine learning approach in that case. So earlier days, the people also have a very good accuracy with the help of these statistical methods or some probabilistic methods or some signal processing method to make the intelligence system. And the fourth one and last one is the human-machine interaction. So how human feels that the person, that machine is working, what is their experience, how they can collect the experience. So for that one, UI UX is required. So your smartphone screen is the best example of UI UX. Whatever you want to enter, you can use the touch screen. Whatever you want to see, you can use the display. So that means the UI UX is the display, UI UX is the touch screen, and based on the touch screen and display, they can take the action and generate the results and all of the things. So this is the fourth one is the main component of an IoT, that how the users feel the experience. So say for example here, the name display on the screen is the UI UX. And so a person can see their name. That means they understand that all these are doing only for me. That is not a randomness. There is no just some averaging all for this thing. That means the system is working. System is not taking any random decisions or all other things. So sensor sense the environment, communicate this information to the server and result to the client. Machine learning adds the intelligence, and all these three components make some decision, and how the users feel, how user can see the decision. Because of that things you are required the UI and UX. So this is the way that we can break out the IoT in the different component using the machine learning. And here that is the left side of the picture thing that the devices are there. They have the sensor, they sense the environment, collect the information, and transmit to the cloud. How they can transmit to the cloud? Using the gateway. Gateway is required for communication purpose or for connectivity purpose between the end user and the cloud. If client can directly connect it with the cloud, then well and good, we can remove the gateway. Usually we assume that the gateway is there because the cloud is so far so from the end user. And the cloud had the machine learning models and other things, so analytical approach is there. They have the data analytics or data mining approaches are there in that case to generate the result, to filter out the result, and finally display the result on the end user. So this is the way that we move in this path. Devices or things are there. They collect the data so using the sensors or any other way. Wirelessly or wired, they transmit this information to the gateway, to the cloud. Cloud store the information, cloud process the information, and analytics generate the results and other things, and find out the meaningful information, and they transmit this result to the user interference, transmit this information to the end user. So once all these components are ready, we assume that the IoT is ready for the useful purpose. So, and these are the example that the sensor technology comes from the smartphone and Arduino and other things. So this slide shows that how we can make an IoT end-to-end solution or what components are there. So sensor technology, smartphone and Arduinos are example of the sensor technology. Communication technology like Bluetooth or Wi-Fi. So BLE and Bluetooth are the different. Please keep in mind. Right now the smartphone use the BLE, and BLE has the Bluetooth Low Energy Protocol. So both are the different protocol stack or protocol architecture. Bluetooth is the normal protocol. They simply broadcast. They are not worried about the energy consumption, but BLE is worried about the energy consumption. They reduce the energy consumption. Of course, the Wi-Fi is the long-range communication. If you want to communicate this information longer distance, if you want to communicate this the decision or some more than the Bluetooth, then we use the Wi-Fi. And Bluetooth is the star topology. That is the another important point. Star topology, that means one sender is there, other one is the receiver is there, and one-to-one communication. Bluetooth also have the limited. And that means clients support is there. That means they can support up to the 8 clients at the same time. Not possible more than that one. So that type of constraints are there in Bluetooth. But the advantage of the Bluetooth is their low power consumption. Bluetooth power consumption is lesser than the Wi-Fi. Of course, I'm not saying that this is the least power consumption communication protocol. Other communication protocols consume the lesser than the Bluetooth, but yes, they consume the lesser power than Wi-Fi because of the communication range is less, because of the limited connectivity of the end users. Machine learning algorithm, most of the 10 machine learning algorithms are sufficient for IoT machine learning application or smart environment. Otherwise, the numbers of other machine learning, but important machine learning algorithm, if we go through 8 to 10 machine learning algorithms are sufficient to make environment into the smart environment. And Arduino phones or Arduino environment is good for the UI UX. So if you have the resources in terms of the human knowledge, resources in terms of the devices, you can make a complete IoT solution using a smartphone, using Arduino, using Android, using BLE or Wi-Fi, and some machine learning algorithm knowledge. So if you have these things, you can easily make one complete IoT, smart IoT scenario in that case. Now, if we are completely familiar with IoT, if we are aware about the use case scenario, if we are aware about the components of the IoT, we need to move on the second section, machine learning. So IoT helps to communicate the information, IoT helps to collect the information, but IoT has a one intelligence is required in the IoT. IoT has a one component that called as the intelligence that called it the machine learning. So machine learning is the component of that IoT, as we already seen that earlier. So we need to go to the narrow down our this one. That means IoT is a bigger domain, machine learning is a subdomain of that one, like this one. So when we talk about the machine learning, a standard definition is as shown on your screen, that this is a standard definition. In this standard definition, there are 3 things are important. ETP. E is the experience, T is the task, P is the performance measures. So very first experience comes into the picture. Whenever we talk about the machine learning, you need to have some experience. Okay. The second is the task. You need to do something. Without objectives, without tasks, what machine will do? So machine needs some task. Machine have some dedicated task is required. So if you have no such objectives, if you have no goal, your machine running infinite time, because of you have no such task. So you need to decide that task very first, that I want these things from this machine learning model. If you have no such in your mind that I want these things from this one, then what else you will do? If you have huge data set, you have good machine learning algorithm, multiple GPUs are there, but there's nothing to be useful if task is not there. So you need to decide that task very first. And the problem is this one. That means most of these student projects, they are not task oriented. That means they can do anything. Okay. And whatever they are working, let's say, for example, they detect the accuracy definition in terms of precision recall. And someone says that accuracy in terms of F1 score. They need to decide that task on which parameters you say this is the accurate or this is not an accurate. Okay. So task is not only the accuracy. Task is accuracy with respect to what? False positive or true negative, like this one. So task, finalize the task is the important. And also how we can check this machine learning model is working perfectly. You need to have some performance measurement, performance parameters. Otherwise, if there is no parameter, no That means when standard is there, then we say that, oh, this is the good. Okay. So say for example, these slides are good because we have not other slides. If we have the other slide, then okay, we can say this slide is the good one or other slide is good. So metrics is, and these performance metrics you need to decide before you are doing anything else. Don't think so that first we design a machine learning model because we have the data set, we have the task, and then we will decide that, okay, at the time of result, the draw and other things, that time we will decide what parameters we will consider. First, you need to consider the parameters. What parameters you will select at in terms of the performance measurement, or what comparison you will consider. And we compare this one work with that one, if that is on the same platform. Otherwise, nothing with it. So all these things are important. If you miss one thing, that means you are not able to make a machine learning model. So very first, you need to decide your goal, your task. If you have some task, if you have some goal, you need to have some experience. Right now, machine learning data set is called as experience. The data set is your experience. That means in the past history, I know that, okay, this person wants 24-degree temperature or 28-degree temperature. Usually, they want 28-degree temperature. This is the experience. Okay, that is the past history, past their willingness is there. So usually when they use the manual AC, so whenever they enter inside the room, they set the air condition temperature is 28-degree. So machine learns this temperature. That means always they have the 28-degree temperature. So whenever the person enter inside the room, they automatically adjust 28-degree temperature. They are not required any man-made effect for that one, that what temperature is required. They are not required to ask to the person that, okay, you feel comfortable or not. The machine knows that, okay, this person is feel comfortable because their experience says that they always use the 28-degree temperature. And accuracy measurement and other things are required. So say for example, for the accuracy purpose in this model, if they have 28-degree temperature, machine set the 28-degree temperature, assume that. But remote air condition remote is there. So if person use the air condition remote even after your machine learning model, that means your accuracy model is not working perfectly. Why they are required to change the temperature? Because of your model is not perfect. You need to design the model. Initially, the temperature is 26, 27 degree whenever person enter inside the room because they feel it and hot. Then after they automatically reduce the temperature, and then after they set all these things. So now we assume that you are familiar with the machine learning definition. So please keep in mind that before you design a model, you need to have all these things. Otherwise, there is no meaning for that one model. A very interesting story is that right now all these BTech students, second year, third year, when you ask that, okay, in which domain you want to project, I want to do machine learning project. So whether that earlier, before the machine learning, that there is no solution is exist. Yes, the solution will exist there, and the traditional programming is also there. So we need to think about that, whether we are really required the machine learning or unnecessary we use the machine learning because of the fancy keyword. So you need to decide that based on your three keywords: your task, your performance, and your experience. If you feel that, okay, you need a machine learning, then only you can use the machine learning. Otherwise, the traditional programming or traditional algorithm is more than sufficient, because of maybe possible in the traditional programming, you are not required any one of these three things. So unnecessarily force that, okay, use the machine learning. So this is an example scenario. You have the same information input, accelerometer data. Accelerometer is a one sensor that is also inside your smartphone. Usually we use the keyword IMU unit, inertial measurement unit, and IMU, they have the accelerometer, gyro, and compass. And accelerometer record the changes in the velocity, how fast your velocity will change, that is the accelerometer. That means you are walking so fast, then slow, then fast, then slow, then accelerometer changes is very high. So for walking, running, jogging, and all these activities, we can easily detect with the help of accelerometer. Say, for example, you are running and suddenly you are walking and suddenly you stop. That means the changes in the velocity is very effective. Then the accelerometer easily detects that whether you are running or whether you are walking or whether you are standing like this one. So that is the accelerometer data, and it's very helpful. So both cases, traditional programming as well as machine learning, they use the accelerometer to identify the human activities. walking, running, jogging, whatever they are doing. Now one black box is there. The black box is this one black box. Here they use the computer programming, and in that case they use the machine learning algorithm. In case of the computer programming, that is the hard-coded instructions are there. You already prefix some threshold like this one. But machine learning, they learn from the continuous data, a recent continuous data, and based on that one, they learn their model and take the decisions. But the computer programming is the hard-coded programming language. And as outcome, both are the outcome are the same, that activity, either walking, running, this is programmed, and this is the rule-based. If this is there, then that one is there. So if you go to the next slide, that is much more interesting, and this slide is available on MATLAB. So MATLAB gives the both type of algorithm, and they compare these things, whether we use the machine learning or this one. So these slides I have taken from the MATLAB tutorials. So human activity detection is your task. Task is already fixed. Accuracy is required as good as the activity recognized. That means you need a good accuracy. So when we talk about the traditional algorithm, this is the traditional algorithm. Of course, both they use the accelerometer sensor. This is also using the accelerometer. They also use the accelerometer sensor. And computer program is there, machine learning is there. But here in this case, accelerometer sensor is there. They detect the values, and they write the handwritten formulas or handwritten equation. If accelerometer values x-axis is more than 0.5, then they are setting. If y-axis of accelerometer is greater than less than 4 and greater than 5 at the z-axis, then they are standing. These are the hard-coded like this one. And they also, based on this one, they make some equations or make some formulas like this one. That means everything is static. Based on the past history, based on their own analysis, they find out these 0.54 or 0.544 values with the help of their own exercise. And they said that if accelerometer x-axis is greater than 0.5, they are sitting. Otherwise, they are standing in these two cases. Based on that one, they design some statistical equations. And in this static equation, they put these values and find out the result. So this is a standard approach. We come to the machine learning. Machine learning is a one curve fitting equation like this one, and use the input, the sensor values, and generate the output as activities, and based on the label data set, what labels you have given. So label is input data. Every rows, they have some label that if this is the accelerometer value, they are standing. This is the accelerometer value, they are walking, they are sitting like this one. So every observation is there. Each observation has some labels, and based on that label, they decide that whether they are walking, they are running like this one. So here the softness is there in machine learning. Here toughness is there. You already fixed the threshold. That means very frequently you are not able to change your threshold. But here the model is quite simple and very low processing is required. A simple calculator is like this one type of the device is more than sufficient to detect like this one. So everything has their pros and cons. So we can't say that every time we are required the machine learning. If my experience, if the mathematics, if the probability statistics is very good, if they're working perfectly, they find out the 0.5, 4 and 5 with the help of huge exercise, then it's quite simple to find out. And they give the better accuracy and the equal accuracy as machine learning algorithm. But if you're not able to find out the 0.545 or 0.545 varies based on the user heights, based on the user weights and other things, then machine learning model is the better than in that case. So you need to decide when you have the problem, in which direction you want to go. You want to go in the machine learning direction or you want to go in the traditional learning direction. So if you want to go in the machine learning direction, right now people are focused on the traditional machine learning, that's why we go to the machine learning direction. So I think so everyone is familiar with this one, but if for the completeness we assume that, so that is the machine learning, they have the two phases are there. One is the training phase, other one is the testing phase. Testing phase, we can say the prediction phase also. In the machine learning, these are the steps are there. One, you have a huge data set. You need to load the data set inside the model. They do the pre-processing or process the data set. That means the filter the noise, fill some empty spaces there, some data you are not able to collect because of the communication errors, because of the other errors. So you need to do the pre-processing. And in pre-processing, you can filter out the data And once you filter out the data, your data is ready. You use the machine learning model for classification or for whatever purpose is there and train the model. So here the training of the model ultimately find out a curve fitting equation like this one. So here like this one, these are the trained models. So this is for example, this is a clustered model. So one cluster is there, other one cluster is there, third one cluster is there. This is the training model. This is also a training model. They find out the curve fitting equation. So that side of element is different as that side of element. This is also the one equation. That side of element is different as compared to this side of element is. So all these are the that means the machine learning model. They train the model based on the data set based on that. Now after training, you can use this trained model in future for the testing purpose or for production purpose. Here you are not required to train once again. So in the future, when you use this solution, when you use this system in practically, you have the new data set. Of course, you need to do the pre-processing of the input data, of the raw data, and when your data is there, you train the model. When you train the model, you can use the model. So this is the trained model directly we can use. But here one thing is very interesting, this arrow. So what we will do in the training time, we train again and again. Because more training, good data is helpful for us. So training again and again is always helpful. So that's where here we have one dotted line like this one arrow, the rotation like this. So it indicates that you train your model again and again for the same data set or different data set. So this is the way that how machine learning is working. If you go abstract view of the machine learning box action, then you have some data, you have machine learning algorithm, design the hypothesis, which is the equations, which is your machine learning models, machine learning mathematics like this one. Then you tune the perimeters, performance, find out the performance. Performance is not as good as what you are expecting. Go back, change the model, change the layers, or use more data set in that case. Once again, make the hypothesis, check the performance. If performance is good, then well and good. Otherwise, you can continuously moving here and here and here at that and find out a perfect model. If the accuracy is good, then no need to go in that case. At the time of testing, one new data set comes into the picture. Whatever the hypothesis you have learned, you have built, then that is there. You use that one and check the performance and find out the result. So this is the way that how machine learning works in the practical application. One question is very simple. The machine learning is everywhere right now. Okay. Because every one person has the smartphone right now. And that means we are not able to say that smartphone is not there. If a smartphone is there, machine learning is there. Whether you want or you are not interested, machine learning is working at the back side of your smartphone. Okay, you are not familiar with that one, but they recognize, they detect your accuracy, what you are doing. So what you are doing, they detect or they recognize accuracy with the help of the machine learning. So suppose you use the social media, that is also a part of machine learning. Suppose right now we are doing this session, the machine learning working in the backend that okay, that they record some voice, they detect some voice, they detect some presentation keyword that okay, on what topics of the lectures are going on. Like this type of backend exercise is always going on the internet. That means machine learning is everywhere. So anyhow, that means we need to work on the machine learning because of their utility, because of their huge application in the environment. Okay. And this is another example of that one. They use the machine learning for classification of these toys, that is with the help of camera, whether that is the car or not. Now we comes to the machine learning basic algorithm, the regression, classification, and the clustering. Before that, if any participant had any queries or want to discuss, please ask. Any queries there for any participant or want to discuss any point as of now? Okay, chalo, good. So I have one query that anyone, that means they have designed any machine learning model end to end. Anyone has any experience that okay, I have designed one machine learning model, complete end to end model. That means they collect the data set, they train the model, and they deploy the model on the devices like this one. Okay. Okay. And anyone they have designed a model on Google Colab or other things, not deployed, or assume that they have not collected the data set. They just design the model. Okay, fine. So in the remaining slides, we highlight that how to that means find out the scenario where we can deploy the machine learning, or we will share our experience where we deploy the machine learning model in the day-to-day life or nearby our environment. So that is, if you have any question or queries, then definitely you can discuss with us. So I stop it here this session, and the next session we start at 1:30, 1:35, 1:30. So we have the 10-15 minute break, and if anyone has any query, I am here, so they can ask. Okay? So we continue after 20 minutes of this break at 1:30 around. Yeah. Thank you very much. So good afternoon to everyone, and let's continue our session talk. And this talk, we try to cover the smart space and how to make the smart space using machine learning. That is our agenda, and we already seen that about IoT, their use case scenarios, and we also seen the machine learning definition and what is the difference between traditional learning and machine learning. So I assume that that means you are already familiar with this one talk, but here in this talk we take some example, try to example, so that we make some more that means conceptual we can understand, and also find out some more use case scenarios. So now rest of this talk, first we see some machine learning, basic 3 machine learning techniques, and that is very useful in the IoT. And numbers of variants are there, complexities are, algorithms are also there in this path, but here we will see a simple algorithm, and then we see some use case scenario where we have used the machine learning technique. So this is a slide that assume that these are the elements. So very first, of course, we need to have our task, we need to have our experience, and we also need to have our performance metrics. There are 3 already there, and we need to do that thing before we start the machine learning algorithms and other things. So this data set is our experience. That is here the data set is there. 2 types of the fruits are there. One is the apple, and another one is the banana. And apple and banana both are the fruits, and but they also have the subcategories that some fruits are very fresh and some are not. So say for example, one apple is very fresh and this is not a fresh apple like this one. This banana is very fresh and this is not a fresh banana. So if you go to the price point of view, what is the price of the fruits? So of course the apple is costlier than banana. But an apple of that is not a fresh apple and a fresh banana, we need to think about that which one is the better or which one is the higher price. An apple with some, that means olderness is there. It is not a fresh, but the banana is the fresh banana, then the banana is better than the apple in that case. Or we need vice versa like this one. So here we need to think about the machine learning for pricing point of view, that how to decide the price, or when you try to buy that, which one is the beneficiary, that means we purchase the fresh banana or some older apple. So IoT always usually assume that a simple machine learning technique, not a very complex. Here in this talk, we also focus on sensor nodes. That means the machine learning problem solved on the node, not sending on the cloud and other things. So very first technique of the machine learning simple class is the regression. And whenever you open the machine learning book, very first you figure out and find out the regression algorithm. So that means regression start with the question of how to estimate the price of the of a fruit if freshness is given. That means you have the freshness there, and now you need to decide the price of the fruits. Okay, freshness in terms of the days. So say for example, one fruit is 5 days older, other one is the 3 days like this one. So some freshness is given, and based on the freshness, you need to decide the price of the fruits. So here our objective is not to decide directly decide on the type of the fruits. That means you can't say apple is always costlier than banana. And freshness play a major role here to decide the price of the fruits. So and here the x-axis is gone from 100 to 0. That means this is the 100 days older fruits as compared to this is the 0 days. And of course, if 2 fruits are very fresh, that means this the equal freshness, then apple is the costly than banana. That means there are 2 columns are working together. One is of course the freshness. Along with the freshness, the type of the fruits also play a role here in this case. So such type of problems comes into the regression, where you have the multiple inputs. That means multiple columns or multiple dimension of the input. That is type of the fruits, freshness is there, and output is only one, price of the fruits. So price depends on both the things. One is the freshness and another type of the. And regression algorithm or regression machine learning technique target is to find out the curve fitting equation. That means your objective is that to find this equation, this line of the equation. Here you need to draw an equation like this one. Now, this is the objective, how to find this equation. Okay. And if you successfully find this equation, then definitely your objective is over. So your objective is only to find this equation, that how to draw this equation. That if you want to draw the equation, this is the regression algorithm. So if a new fruits comes at this position like this one, so what we can do, we can check the day's freshness and we can find the price like this. If we have this curve fitting equation. So now based on the equation, so say for example, like this one. So there are 2-3 type of the equations are possible here. So this is only for that those they are not familiar with the regression algorithm. So that's why I'm cover here. So say for example, one curve fitting equation like this one, other curve fitting equation like a straight line. So straight line curve fitting is the linear regression. One linear line is there. Logistic regression is like this one, teddy-meddy line. So some turn is there, some teddy-meddy line like this one. So this is the logistic regression. So linear regression has the one curve fitting equation, which is the straight line. But objective is that you need to find the curve fitting equation that covers all the point, whatever points are there. And if new fruits comes into the picture, their freshness is 90. So their freshness is 90 days, or their freshness is around 25 days like this one. So we can easily estimate the price of this one. So this is our objective, this is our agenda of the regression algorithms. If you go to some mathematical way or the some symbolic way, then we can check like this one. So how to estimate the price of the fruits? This is my problem statement if freshness is given. So freshness of the fruit is given and fruits is of course given. That means this is the apple or this is the banana, that point is also given in that case. Then you need to estimate the price of the fruit. This is your problem statement in machine learning. So what input is there? Input is the labeled instances. Labeled instances means you know the price of the fruits. Okay, y-axis is the price of the fruits, x-axis is the freshness in days. So this is the data set is given. That means 2-column data set like this one data set, 2-column data set is given. One column is the freshness, other one column is the their prices like this one. And numbers of instances are given like this. So x is their freshness, that means days, and y is the price of the fruits. There 2 things are given. And the machine learning technique, they find this type of equation x to y. If x you have entered the x, you can easily calculate the value of the y. So predict the y for the given x. So in the future, if any new freshness comes into the picture, you can easily predict the y. Now this is very important. That is in regression, the values are the discrete values of the y. So new fresh or new y of the fruits in the given of the x. So this is the standard definition of the. So most of these that means IoT applications find the regression algorithm. So as we already seen that the objective of the regression is this finding this equation like this equation. If new fruits comes into the picture, the days are given. You need to find the price of the value of that one item in that case. Yeah. Now, different from the regression, the classification comes into the picture. Okay, so classification, that means how to identify, not estimate. So estimation and identification, there are 2 different things are there. So regression, yeah, please.
Yes, sir.
Please, can you please ask? Yeah.
Sir, in general term, what do we mean by regression, sir?
General terms regression, you estimate something by the given of some elements. Some elements means the multiple values of that element. That means you need to estimate regression with respect to some given information. Okay, so
sir, is it opposite of? Sorry to interrupt. Is it opposite of aggression, sir? Regression like this, or something else? Sir? In general terms, sir?
No, I'm not getting opposite to which?
Aggregation.
No. Aggregation is the different thing. Aggregation is the cumulative decision sort of thing. So regression, say for example, if 30 minutes, if we continue this talk, then if you are able to predict the 31st minute what slides comes into the picture, that is the regression sort of thing. But what is the cumulative, what is the sense of these 30-minute talk is the aggregation sort of thing.
Oh, yes, sir.
So if 30 minutes we covers the slide, then 31st minute, or if you miss one slide of 26th minute slide, you can easily predict what in that slide. That means if machine learning is going on, slide is nearby that one topic like this one. That is the some sort of regression. But if we talk about the aggregation, which is summarization of that slide sort of things, what topics they have covered, like this one. So aggregation is complete. Yeah, please.
Actually, previous session I just could not attend. So, what topic was going on, sir, in the previous session, sir?
Today in the previous section, IoT and the details about the IoT and why machine learning is required, whether really machine learning is required or traditional algorithm is sufficient for machine learning. That is.
Thank you, sir. Thank you for explaining, sir.
So, yeah, continue. We continue. So, classification. So, after regression, the classification comes into the picture. Classification is not estimate any value. Estimation is not there. The identification is there. So, very important that the difference between regression, classification, and clustering. Where we need a classification, where we need a regression. So, regression gives a value. That means you need to estimate that values. If someone says to estimate that values, then regression is required. If you identify or group of that one, then classification comes into the picture. So, say for example, that is two class classification. That means either 0 or 1. So, if I have the two class classification, one is the older fruits, and other one is the fresh fruit is there. So, that is the classification. Okay, simple class is there. This is the class 1, and this is the class 2, like this one. So, we are not predicting any value. So if some new element comes into the picture, we need to decide whether this element goes in this class or this element goes in that class. That means we are not required to estimate the price, or we are not required to estimate any value. The elements are moving here or there, like this one. So this is the classification problem. And classification may be possible two-class, multi-class classification. It depends on your use case scenario, depends on the application. So say for example, if we are doing the grading, first division, second division, third division, that is the 3-class classification. If pass or fail, that is the 2-class classification. So whenever you go down, narrow down the classification, that means in place of 2 classes, if you feel that the 4 classes, 5 classes or 10 classes, then you need to have the sufficient data set, otherwise you are not able to find a good accuracy. First division, second division, third division, you need to decide in a very precise way as compared to pass or fail. Pass fail is the bigger class, like this one. So whenever we start work on the classification, whenever you have the data set, you have the problem, very first you take a very simple 2, 3, 4 classes, then after narrow down the classes from subclasses. So say for example, pass or fail. So very first you need to decide based on the mass, based on their attendance, based on the student behavior, based on multiple factors, curriculum activities and other things. We decide that they have the passing marks. Now after passing, you need to decide first, second, third division, rather than directly jump on the first, second, third division. So maybe possible some fail student comes in the third division class, then goes the class accuracy goes down, and the overall accuracy goes down of the system. So whenever we try to solve the problem, we need to use the divide and conquer technique. Divide the bigger problem into the sub problem and then sub problem, not directly where the bottom problem becomes in that case. And another thing is that classification is that be simple way as the regression, because regression you need to estimate the exact value. Classification classes are required in that case. So this is like this one. So here we can see this is the example of classification. These are the fresh fruits in this direction, and these are the older or not a fresh fruit. So there are 2 classes, and the objectives of this classification algorithm is to figure out this line. Whatever the elements in that side is the fresh fruits, whatever the element in that side is not a fresh fruits, like this one. So this is the 2 class of classification. One is the older fruits, not fresh fruits, other one is the fresh fruits, like this one. And objectives of the curve fitting equation is that divide into the 2 classes. So here one interesting thing is that no one element on this line, like this one. So elements either in the left side or in the right side. But if you go to the if you go to the previous slide in the regression, you can see that the elements are on that one line, like this. Okay. So elements are on this line, that is the regression, because you want to estimate exactly. Here in the classification, you are not required to estimate. You have the classes, so elements are either left side or the right side of the elements, like this one. In the machine learning, there is one keyword we always use, the loss function or loss. Loss indicates the error in the system. If high loss, that means high error is there. System is not working perfectly. So can anyone suggest what is the loss in this classification picture? What is that means not as a definition point of view, equation point of view. What we understand the loss function, or what is the loss in machine learning in classification if this image is given here. And anyone can suggest their opinion or have some experience in this case.
Sir, if I will try. After a period of time, the apples will be going to be rotten, no, sir?
Apple will be going into, sorry, I'm not getting.
मतलब सर ये एप्पल कुछ दिन बाद खराब हो सकता है सर?
Yes, definitely. So class, sir, in that case, we need to change their class from fresh to the older one.
Yes.
So that is the learning process. So yes, so what is the loss function, or what is the loss or error in the model? So see that the element distance is the error. So curve fitting equation says that in any case, either linear regression or classification, what is the distance from element to curve fitting equation? So say for example, this is the element and this is their distance. Equivalent distance, or whatever distance is there, there's some distance matrix is there. Equivalent distance means direct one-to-one distance. So this is the distance. This is the element and this is their distance from the line. This is the element and this is their distance from the line. This is the element, this is their distance from the line. This is the element, this is their distance from the line. That is the noise, or that is some sort of the loss. So some cases our objective is to reduce this distance as less as possible. So in the regression case, our objective is to reduce this distance as less as possible. That means our objective is whatever the new element comes into the picture, they are very close with this one line, or put the element on that line. If element is not able to put on that line, then that is the problem. And here also we want to reduce the distance in between. So if the less distance is there, that means we are making a successful clusters in that clustering algorithm. Classification algorithm. So classification
Sir,
of this, yeah, please.
सर ये जो लाइन बीच में बनाया है, ये लाइन सर कैसे डिसाइड करे? लाइन मतलब कहाँ बना सकते हैं, कैसे बनेगा ये लाइन सर?
So ये लाइन बनाना ही क्लासिफिकेशन मशीन लर्निंग एल्गोरिथम का वर्क है ना. वी वांट टू ड्रॉ दिस लाइन. ठीक है, अब एज्यूम करो कि लाइन यहाँ से ड्रॉ कर दी जाए. लाइन यू भी जा सकता था इन प्लेस ऑफ दैट वन, है ना. ये लाइन एज्यूम करो यहाँ से चला गया. सो इन दैट केस व्हाट्स हैपन दैट ये दिस एलिमेंट्स गोज रॉन्ग, है ना. ये चला गया ओल्डर क्लास के अंदर. अगर है ना, इफ यू एज्यूम दैट द लाइन इज लाइक दिस वन, लाइन अगर इधर से जाता, आगे का लाइन बिल्कुल करेक्ट है, कोई प्रॉब्लम नहीं है. एज्यूम दैट है ना, यू कैन ड्रॉ द लाइन लाइक दिस वन. सो दिस इज नॉट ए लाइन. सो व्हाट वी हैव डन, दिस एलिमेंट गोज इन द रॉन्ग क्लास. दैट मींस दिस लाइन गोज, दिस एलिमेंट गोज इन द older fruits class. So yes, in that case, the accuracy is not what we have the accuracy earlier. So what we will do, we once again train the model and find out the new line. The next case, we may be possible find the line like this one. Okay, then this line is correct. That gives the better accuracy as compared to the previous one. So then we can say yes, this is the right. So line drawing of the line itself is the machine learning algorithm. The objective of the machine learning algorithm is to find the line, nothing else. You know? Yes. And now in the linear regression case, the elements on the line, and the classification elements either in left side or right side of that line. If two class classification, if three class classification, then line maybe there are three lines are there. One is this one, another is this one, and third one is that side. So then class 1 elements, class 2 elements, and the class 3 element in 3 class classification. If you go to the 4 class classification, you also need a one more line in that case, like this one. So that is this is the 4 class. There are 4 classes are there. So in the simplicity here, we have the 2 class classification, which is the minimum class classification. Otherwise, one class is not possible. So 2 class, either left side class or right. So the curve fitting equation, the machine learning that find this line, the left side of the fruits are the fresh, right side of the not the fresh fruits like this one. This line we find out based on the data set. So initially what they will do, they randomly, their machine learning, what they will do initially, they randomly draw line like this one. Okay, then they check that, oh, this is the fresh fruits, why they are in that side, why not this side. So they are not able to change the position of the fruits. They can change the position of the line, so they can shift the line from this one. Then these fruits comes into the correct position. These are correct position, but these fruits have some problem. These fruits also have some problem. Then what they will do, they can move the line like this one. Then they say that, oh, these fruits comes into the correct line, but these fruits are in the wrong line. So then what they will do, they move the line like this one. And finally, hit and try exercise, they figure out and they find out this one line. And then once we have this line, we check that, okay, all the elements are in the correct position. That means this line is the correct for the classification purpose. So if a new element comes into the picture, if the new element like this one and this one matrix, you can put the new element at this place. That means that is, if the fruits is the fresh fruits, then your accuracy is high. If fruits is the older and at this position, then your line is not working perfectly. You need to redraw the line like this one, not that one line. So this machine learning automatically will do equations on the mathematics of the machine learning will do all these exercises. And finally, we have this type of the line. Yeah. Please. Yes.
Okay. So how to decide the line should be a straight line like linear, and how to decide the line should be in curved line, that is a logistics, so on what basis, sir?
Yes. So if they say in the machine learning algorithm mathematics, we need to put the curve fitting equation. If you want linear regression, then you need to use the line equation, linear line equation, y equals to wx plus b. If you heard about y equals to wx plus b, that is the linear regression equation. So whatever the values are there, that is, so if I try to write here, maybe possible I am correct. So y equals to wx plus b. This is the linear regression equation. So in the curve fitting or in the non-linear, that means the line is not linear. So in that case, what we will do, we can write y equals to function of x, w, and b, like this one line. So this equation is the non-linear curve fitting, non-linear regression is there. So in that case, maybe possible this is somehow x square, w x square plus b. So this is the non-linear line equation like this one. So it depends on that means what equation you have given to the machine learning model. So if you give the linear equation, then like this one. If you non-linear, then this one. So now what machine learning?
Sir, here non-linear means, sir, logistic regression, no? Or it is different, sir? Non-linear means?
Yes, logistic regression is one type of the non-linear equation.
Yes, sir. Thank you, sir.
Maybe possible. Yeah.
Yes, sir. Sorry to interrupt again. So my concern is how to decide the line should be straight, like linear, or lines when the line should be curved in logistic regression. What conditions, sir?
See, initially, say for example, you take the line linear regression, very simple, and check the loss function. If your loss function is very high as compared to logistic regression, then you need to go to the logistic regression. There is no straightforward way we can say linear is correct or logistic is suitable for this one case. So we can go from simple to the complex case. First we take the linear regression.
Yes.
That other way is that if you use the logistic regression, so logistic regression automatically have the linear regression itself. See, the reason why I am saying that in the linear regression, the line equation is y equals to wx plus b. Okay. And in the logistic regression or non-linear regression like this one, if we talk, then the equation is something non-linear like this. Yes, y equals to w x raised to power something. Assume that w x raised to power p plus b, and where p is greater than 0. Okay, so what they will do, initially they try the p equals to 1. P equals to 1, that means the logistic regression or non-linear regression, logarithmic regression is somehow some part of the linear regression. So linear regression is always inside the logistic regression. So logistic regression is super domain, linear regression is somehow this one. That means the complex problem is the part of the simple. So very first they assume that we can try to line a straight line. and check that whether element on the line or not. This element missed that line, because of the linear line you have tried to draw. Then what they will do, they add the softness and try to add like this type of the line. Then they figure out your logistic regression or non-linear equation is better fitting as compared to linear equation in that case. So
Thank you for nice explanation, sir.
Yeah. So the point is that if you have sufficient data set, if you have sufficient processing power, then all these things are possible. You can do hit and try, you can take more data set, but if you have limited data set, or if you have not such processing power limited, then what you will do, you are not trained all the data set, you can select some element and train only on the data set. In that case, that problem is there, and we are not able to find out a good accuracy in that case if you are using that one. So this is the classification, and this is the example of the two-class classification. Because of that, only two classes are there: fresh fruit and not a fresh fruits. And you try to find out this equation. This is the machine learning equation that you need to find out. Whenever someone says that, okay, what is the meaning of loss function? We can say that this is the loss function, the distance of elements in that case. So if you go to the definition point of view, the problem statement of classification is the same as how to identify whether fruits is fresh or not. Identify, that means you need to decide that fruits is fresh in that category, not fresh in that category. So you need to take the decision whether identify that fruits is fresh or not. So very first you have the input. Input is the freshness, and that is in which class they will go, days and the freshness, or the type of the fruits and the freshness. This is the given input. Your objective is to find that curve fitting equation, that the line equation with the alpha function. X is given, what is the value of the y. And here, different from the that is the regression, this is the real value. In the regression, we say that the discrete values here, if you go to the discrete values. But in this classification, you can see that this is the values is the real value in that case. So this is the classification, and this is the distance that indicate the loss of this one, and our objective is to reduce this one. Third one is the clustering. This is the last one algorithm that usually machine learning with IoT use that one. So one is the regression, other one is the classification, then clustering comes into the picture. The clustering is the same as the classification, but here that is the unsupervised. Unsupervised means at the beginning, no one has given that this is the fresh fruit, or this is the older fruits, or this is the banana, or this is the apple, like this one. That means there is no monitoring body, there is no labels is given. You need to decide, you need to put these fruits in this bucket or in that bucket. It depends on you. Okay, that type of cases comes into the clustering. So clusters, you need to make the cluster set. That is if there are the two buckets are there, you can make two cluster based on your experience. So what experience is there? So assume that you already have the two buckets. One bucket is there, other one bucket is there. Someone gives this one bucket. Now new elements comes into the picture. The objective is that whether this go in this bucket or in that one bucket. There is no other, that means guidelines is given. But when we see the element, we see that this is somehow the red color or green color. There's something is circular shape like this one. Then very easily the machine learning can identify that, okay, this is not a banana, this is the apple. Why? Because of their shape. If that is the circular shape like this one, that is the red color, or like something like the green color, then definitely that is a part of this one. Okay, not that one. So this is the unsupervised way. That means we have not given any label where this is the banana or this is the apple. No, we have not given anything else. We have only the features of that input items. Features is their color, features is their shape. So whenever one image comes into the picture of that fruits, the image recognizes the shape, that is the circular shape, that is the green color, or that is the red color, or that is the yellow color. Based on the color, based on the shape, they will automatically move either in this bucket or in that one bucket. Yeah, please. Any queries there? Any point anyone wants to discuss?
Yes, sir.
Please.
Hello.
Yes.
Sir, during analysis, whether we can ignore some of the items during the filtering process, and means some form of outlier analysis. If we will ignore some element which is out of the basket, then whether such
Yes.
makes some big difference in the result. So whether it is a biased result or it is allowed.
So before we use this very interesting point is that whether we need to avoid some that instances or not. So the point is that if you're before machine learning, you need to do the pre-processing or data mining. If your data mining pre-processing is so strong, then definitely you can easily avoid the elements. Or the elements are complete black and white. Say for example, room temperature. If we try to train a model for the room temperature, it is not possible 98-degree room temperature. That is the room temperature between 20 to 40 degree, assume that. And somehow range is in between. Suppose the velocity of a bike is vehicle speed is possible 60 to 120 degree, 130 degree, not 230 or 240. So if some elements or some instances by the mistake or by some intentionally wrong labeled that this is the 240 degree, 240 kilometer per hour is the speed of the bike, that is not possible. So in that case, definitely we need to remove. And this is the part of, or this is the duty of the data pre-processing or data mining, not the machine learning. Machine learning is not that is the right position where we can remove the element or not. Machine learning, whatever you have given the information, they will start training of that elements. But before machine learning, we need to do the pre-processing, and this is the duty of the pre-processing. And effective pre-processing, data mining, data analytics approaches, they can remove these outliers. They are anyhow not in that range. And how we can find out the outlier? Multiple mathematics analysis is given. Say for example, mean or standard deviation or average is there. Mean values. So whatever the elements, whatever the observation nearby the mean values, we can consider only that one. So assume that when a property price is there, and when the property price says that the 10,000 rupees rent in this area, this is the mean value, or this is the average value. And we can go up to the 15,000, 20,000 for training purpose. That is the price of the property versus the location of the area. But we can't consider 85,000 rupees, and we are not able to consider 2,000 rupees. So figure out the average or the mean cost in that area, and whatever the elements nearby that mean values, we can consider based on capability of the machine learning models, whatever they can train up to what range they can. So whatever the radius is there, radius goes from 10,000 is there, values is the mean, then we can consider up to the 5,000 to the 50,000 or 20,000. We can't consider the 2,000, or we are not able to consider that 85,000. So outliers, anyhow you need to remove. Otherwise, what's happened that your model goes in a wrong direction. Because of you are considered the outliers, and outliers is not a correct, then models are confused, model is confused, then definitely they will go in the wrong direction. So there are two reasons why the models are not working, even you are doing a perfect machine learning models or training, huge training, another thing. One is the wrong instances. You have not pre-processed properly, you are not using machine learning, data mining or data analytics approach. Because of that things, the outliers is there, noisy data is there, incomplete data is there, and that incomplete, noisy or outliers data used in the time of the training of the models. So that machine learning reply is not there. That's where we go in the wrong direction. Another reason is that not the outliers but biased data set. That is also the another major problem in the machine learning. That is not the outliers. They are the correct data, but towards the biased. Biasing may be possible. Say for example, if you consider the activity data set, walking, running, jogging, if most of the data set of the walking, then running and jogging is not able to predict perfectly. Even they are running, but they still say the walking. Why? Because of this is the biased data set. 80% instances are walking, 20% instances are remaining activities. Then how the model can train perfectly? So outliers or noisy data set is the one problem. Biasing in the data set, unequal classes distribution is the another problem. Some somewhat the very, very interesting problem comes into the picture. That is, the real life problems are there. So what's happened that all these models, whatever the machine learning models today we are using, earlier they trained on the US or the UK data set, traffic information monitoring. This is, if you do the Google or Wiki, you can figure out this problem. So most of these models are trained in UK or European countries at the early days, and their data set is a white-face data set. So they can very easily detect the white face, but not able to detect the darkness or other things, so faces in that case. So that is the way, that means traffic information or identify the face recognized models are biased. Why? Because their training is only the white face. Now, of course, the data set increase and heterogeneity comes into the picture. Models are working perfectly, but earlier that based on the face recognize and unlocking of the laptops and other things, earlier days they are not working only because of they are trained on the white face data set. Now people are using continuously, then that problem goes down. Another recently problem comes these Amazon and other things, recruitment time. They also figure out the biased data set in their CV. So what's happened that in the CV, those they have done the BTech and other things in 2008, 2006 or that time, their CV they write the language C, C++, Turbo C or that type of that means that type of languages. Those they are working in that time, not right now. And current CVs they write the Python, they write other languages, whatever they are currently going on. So the machine learning model trained on the older techniques data set. So very first way, say for example, you submit the CV and that time, that means the not HR and other things. Very first, the machine learning model, they filter out whether the CV is suitable for their company or not. First level of screening. So how they can do the first level of screening? Based on the training. How they can train? Based on the previous resume. Previous resume, whatever the employees are working in that company, they are write in their resume because they are working in the company since 2004-5 and that time they submitted their CV, they recruit in their company and model trend based on the existing employees, and existing employees keyword says that they have the good knowledge of Turbo C++, VC and Visual Studios and other things. So what models they have done, they figure out that keywords, if such keywords are in their CV, they filter out and otherwise they reject it. So whatever the newly technology CVs are there, they write the machine learning models, Python, the CVs are rejected by the machine learning model. They are not sent the second level. Why? Because of the model is biased towards that older techniques. So this is that we need to take, even machine learning model is working perfectly, everything is perfect. So then they recognize that why proper CVs are not coming and why good CVs are rejected. So then they do all these exercises. Then they figure out, we train the model based on our existing employee CVs. And our existing employees are 2002, 2004, 2005 employees CVs. So that time the technologies are different, current technologies are different. So this type of problems are there. All these are the data mining, data pre-processing problems are there. So if outliers is there, biased data set is there, noisy data set is there. All these things we need to take care before we designing or proposing the machine learning model. Otherwise, machine learning model is not able to filter out or not capable for handling all these type of the challenges. Yeah. Any other point from your side? Anyone want to add something here? So this CV sorting or the CV selection or rejection is that means the huge problem comes into the picture when you go to the internet. You find out this whatever that automatic CV or profile screening, they have that type of problems based on the degree, based on the technologies, their model trend on older technology and all. Say for example, earlier the Bachelor of Engineering comes into the picture. Right now, BTech comes into the picture. So they select the B if they have the B degree or not, like this one. So that is the also the that means overtraining or training in a specific keyword like this one. So chalo, we once again return back to this one. So clustering is an unsupervised machine learning technique. That is, there is no supervisor, no one is observer is there. No one is working for you. You need to decide your own. There is no y-axis is given. So here what we will do based on the features. Features is their shape of the item, color of the item like this one. And based on the shape and the color of the item, we can decide that whether this item goes in this bucket or item goes in that one buckets. So Here very simple, there is no y-axis, only x-axis is given. X-axis is a vector is there, not one element. This is the vector. Vector means more than one elements are possible in that x-axis. Here say for example shape and color, there are two elements are there. To find out a proper bucket, you know, so to finding the proper bucket we need two elements. One is the color, other one is the shape. So x1 is not an integer value, x1 is the array or x1 is a vector in that case. And of course the overall objective is to data distribution in a proper way, and the outcome is the grouping of that one elements. So we have seen the three techniques. This is the almost common techniques that in IoT people are using, and they're very old techniques now. That means everyone knows about, I think so. So this is the regression, estimation. This is the classification, identification. This is the clustering. So these two are the supervised. Some y-axis is given. Here there is no y-axis is given. And one interesting fact is there, if you have the y-axis in clustering, say for example you have the two clusters, one is the banana, other one is the apple. You know? And if y-axis is the noisy y-axis, then better you can use the unsupervised machine learning technique rather than supervised machine learning technique. That is a very interesting that you need to move from supervised to unsupervised if y-axis is not given, or if the y-axis is given but they have the noise and a noisy y-axis. That means the wrong y labels are there. Someone is write banana in place of the apple in the y-axis. So then in that case you can use the unsupervised machine learning technique. Now one new question comes into the mind, that why wrong labels? How it is possible a person can write the apple in place of banana, even this is the banana, why they have write the apples? So there are multiple reasons are there. One reason is that of course the lack of the knowledge of the expert. Of course this is a very simple example, banana and apple, but if some medical disease are there, then very tough to use the correct word of the disease. So what they will do, they write the nearby the disease. That is the one problem is there. Another problem why the y-axis is wrong, because of machine learning labeling. Right now people are so busy and very costly manpower. So what these companies are doing, they are doing the labeling with the help of some machine learning models. They capture the image, recognize the shape of image and label the items of that image. So say for example they capture my face and say this is the angry, this is the happy, or this is the sad. So this is not a man-made label. The model automatically labeled on that one. And of course the model has the limitation, that's why they do the wrong labeling. So first reason of wrong labeling is that if we use the manpower has no such sufficient knowledge whether what is the name of this perfect disease. What they will do, they write the nearby that name. Another reason is that this is not done by man-made exercise. This is done by some machine learning, and they do the labeling of, they see your X-ray image and say that okay, they have this type of congestion is there. This is a machine learning result. Machine learning labels are there. So machine learning they generate some noise, and based on that noise your y-axis is wrong. Third and the last one reason is that because of all these results are communicated using communication channels and other things. So maybe possible the communication noise is there, and because of that reason the result goes wrong. So say for example there are 4 classes are there, you do the classification with the labels 0, 0, 0, 1, 1, 0, 1, 1. There are 4 binary 4 classes are there, and we use the binary labels 0, 0, 0, 1, 1, 0, 1, 1. When you use the wireless communication, in place of 0, 0 at the receiver side receive the 0, 1. The labels are the wrong. You go in the wrong class. Or maybe possible some attacker is there, some virus is there, they play with your labels, they modify it, they temper your labels. So these are the challenges that we need to take care about supervised machine learning technique. And if you find that your labels are not correct because of any reason of these 3, 4, person is not doing correctly labels, machine learning is not doing correctly labels, or even the labels are correct, but at the time of communication noise is there, or someone is tempering in your labels. So all these things, supervised is not working perfectly, you need to move to the unsupervised machine learning technique, in that case where y-axis is not required. These are some examples of the supervised and unsupervised. Usually we use in IoT and machine learning. One is the decision tree, nearest neighbor methods, regression and classification. Usually these are the non-supervised, unsupervised machine learning techniques. Unsupervised, the clustering, we already seen that dimension reduction is the unsupervised machine learning technique. Why dimension reduction is required? So that you can reduce the complexity of the systems. If you have high dimension data set, you need a huge processing power in that case. And of course, in this talk, in this workshop, we covers these machine learning techniques here and there. Now, after this, we assume that you are familiar with IoT, you are familiar with the machine learning, you are also familiar how to use the machine learning in IoT. We cover some applications of this technique that we have using in the IIT BHU Varanasi right now. Or these are the contribution of my PhD students here onwards. So here we can see that how to convert this environment into the smart environment. That is our title, that use the machine learning, convert environment into the smart environment or smart home, like this one. So this is a scenario, this picture. Here you can see that one older person is there inside the home. And objective is to detect or recognize their activity, what they are doing. They are walking, they are running, they are sitting, they are lying, what they are doing. We need to detect that one. And this is the house, or this is a space. We need to convert into the smart space. That means recognize their activities. So very first step, you need to deploy the sensors. So this is the sensor. If they see the TV, they detect, yes, they see the TV. If they are going outside, they are coming inside, this sensor detect the coming and going outside. That means outside activity. How much time they spend outside the home, then how much time they spend inside the home. This is the activity, so they can detect with the help of sensor. So sensor detect that whenever they are going outside, whenever they are coming inside. How much time they spend on the couch, this sensor, proximity sensor detect, because only one person inside the home. So they can easily detect they spend some time on the couch or not. What is their sleeping activity, whether they are sleeping or not. If sleeping, whether they are deep sleep or they are not perfectly sleep, they sleep only half an hour, then wake up and then half an hour, like this one. So this sensor is required for sleeping activity recognize. This is the washroom sensor that detect that how much time they use the toiletry and other things. This sensor, with the help of this sensor, we can detect like this one. This is the sensors, they detect the walking or something activities they are doing or not. So all these sensors helps to detect their activities, what they are doing, and how much time they are doing when they are doing this activity. So what activity they are doing, when they are doing, or where they are doing these activities, with the help of these sensors, very easily we can detect. Now the second objective is that how to communicate this information to the base station or to the end user. Sometimes what's happened that these sensors read some values, but they are not able to take the decision. Decision is, of course, use the machine learning. Decision is also required some other part of information, say for example, aggregation of the information. So that means in that case, we need to transmit this information somehow on some server, some cloud. They have the other additional part of this one. Okay. So this sensor, they detect that with the help of proximity sensor, with the help of magnetic sensor, we can detect one person is nearby this one. But still they are not able to take the final decision whether they see the TV or they are just sitting here. So that type of information, they need to communicate to the cloud. And of course, the IoT consists of 4 components: sensing, communication, processing, and UI UX. So sensing is okay, sense the information. Now come to the communication part is there. So for the communication part, here this red color line indicate sensor and sensor communication within a one device that is inside their home. Okay. And these sensors are the battery sensors, and sensor nodes are the battery powered sensor nodes, and the battery is limited. So we can't assume high power consumption communication protocols. So in that case, we need to use even low energy power consumption communication protocol. So here you can see the 2 abbreviations, SRC and LRC. SRC for short range communication, LRC for long range communication. Short range communication within the home is required. That means the sensor communicate from this to this one, the sensor communicate from this to that one. This is the short range communication. For example, Bluetooth low energy, BLE. Your smartphone has one Bluetooth communication is there. That is the short range communication. So this sensor says the BLE radio. They communicate with each other. This sensor is the BLE radio. This laptop is the BLE communication. So they can collect this information. So whatever the information are there, they communicate from sensor to sensor, sensor to sensor, sensor to this processing unit inside that home. And all these things we use the BLE or somehow short range communication protocols. So that is the SRC. Now short range communication protocol communicate this information to a device which is inside that home. Since this device is inside that home, we are not assuming they have the GPU, CPU and device, a very high-end device, and that is very, very challenging. The people are not able to afford that one and not required that type of devices. So what they will do, they try to process this information up to a certain level. If they process this information successfully, then well and good. Say for example, the sudden fall is there. They try to process this information. If they process this information successfully, then they generate the alarm outside the door. When bell is there, they start ringing the bell. They also call to the helper, whatever the help take care person is there. All these things they will do at their own end. So that means they have some processing power. They use their processing power to identify the activities, but up to a certain level. Because of the limited processing, limited information. Information means the past data set or limited other resources. Other resources means they have no such data set of other house. They have data set only within that house. So this is a limited data set, is there, limited processing there. So they try to solve this problem. If they solve this problem, then well and good. If they are not able to solve this problem, they forward this problem to the high-end machine. Okay, using the long-range communication, such as LoRa, such as 5G, 4G, 6G. These are the high power consumption protocols. They consume huge power and they communicate up to the some kilometers. So if we use the cellular network, SIM is there, chip is there, the 5G is there, they can communicate this information to the longer distance, 4 or 5 kilometers and more than that one. Or where they want to communicate, they can communicate easily in this information. Because of this information, communicate via edge device. Edge device is some laptop, some system is there. So we are not much worried about the power consumption. These nodes are the battery powered. Here we are not able to assume that each node communicate this information to the cloud because of the power consumption and processing process. Here they have the power because of this is a dedicated device. Connected device is there. They are always connected with the power. So say for example, maybe possible in your home you have the routers. Router is powered by the plug and play. So they have the continuous power supply. So router is not worried about the power, but your smartphone worried about the power. So these sensors not have the limited power. Here we need to use the short range communication and energy efficient protocol. Here they have the dedicated power supply. So we are not much worried about the power consumption as compared to the short range communication protocol. Now fog computing is a fog device. They try to solve this problem. When usually they solve the problem. When they solve the problem, they try to connect with the end user where they want to share this result. If they direct connected with the end user, then well and good. Otherwise, what they will do, they can put this information to the cloud. Cloud means, say for example, Amazon Cloud, AWS, or Google Cloud. And they put this information to the cloud. If they are not able to directly connect with the end user, they put this information to the cloud. Cloud this and share this information to the end user. So say for example, right now we are using the Google Meet. Okay. So what I will do, I have one laptop. Whatever I am talking or speaking or slides, I will put on the Google Cloud. You also connected with the Google Cloud and they sync up between you and me. And that's why we are doing this Google Meet directly. So because I am not able to directly connect it with you, but if you are inside the campus, then we have our own server, we have our own intranet, we can directly communicate with each other. We are not required any third party support in that case. So if the processing unit is out of the range of the end user in the different location and this processing unit is a different location, then definitely you need to use some intermediary body. They connect with these two and here we use the cloud. That is the one reason why we are using the cloud. Another reason is why we are using the cloud. Sometimes the fog device is also not capable to solve the problem because of any reason, processing unit, data set, security and other reasons. So say for example, this person is not trust on this fog device. So what they will do, they try to generate the result up to certain level and remaining information they forward to the cloud via fog device and in an encrypted fashion. And where is the key is there? Key is at the cloud. So this fog device, they have no such key. So how, if they are not able to decrypt this information, how they can process this information? So in that case, definitely we need a cloud. Cloud will decrypt this information first, and then after they process this information. Now the cloud, either cloud process this information or cloud work as a gateway between end user and the fog device. And finally, result is here. They can see the result, they can process the result, they can generate the result in that case. So this is a complete example of a smart environment where some data is generated, data is communicated via edge device to the fog device to the cloud to the end user. Lastly, here we can see that we use the two keywords. One is the edge computing, other one is the fog computing. The definition of edge computing says that is the limited devices which are closer with the end user. So say for example, there are two devices are there. One device is closer with the end user, that is the edge device. One device that is far from the edge user, that is the fog device. Usually we assume that the fog device consists of more processing power than edge device. Fog device has more storage, and when distance is from the end user and the fog device is more than the edge device. Some papers or some research work, they also use one keyword, the leaf devices. Leaf device means a device which is directly connected with the end user. Say for example, a smartwatch is the leaf device. If some smartwatch is there or any one variable device is there, that is the leaf device that is directly connected with the end user. So leaf device that is directly connected with the end user, fog device, they have some processing, edge device, they have some processing that is next to connect with the end user, and the fog device has the more processing power that is compared to the cloud that is closer with the end user, but not as close as the edge or the leaf device, and fog device, then cloud, then the end user. So this is the complete architecture of the smart space, where we need to use all the machine learning technique, all the communication techniques, processing unit, edge, fog, cloud. Then we make one complete end-to-end solution for the smart space. Any point is there? Anyone want to discuss anything else in this smart space solution? So we can go in the next. So this is a scenario that we have designed here. This is a paper that this work we have recently published in one top ranking conference. The objective is that these are the example of how to make a space into the smart space for some suitable candidates. So here one baby is there, a very small baby is there. They are in some walker sort of things, and they have different type of the face expressions. So say for example, they are smiley, they are sad, they are crying, they are hungry, all these things. So based on the camera, based on the sound, you can easily detect what is their expression. That means they are laughing, they are in a cry, they are hungry, whatever they are doing. We can very easily detect with the help of machine learning and IoT. So this work is published in BuildSys conference, and here our contribution is to design a device, and this device is based on this baby walker, baby machine, and the device has microphone, because they recognize the voice of this baby, whether they are crying, they are laughing, what they are doing. They can detect, they can recognize, and they can communicate to the server for further classification. They have the speaker. If speakers are for generating the sound based on the action. Say for example, they are crying, so speaker generate or speaker starts some song sort of thing, or some that means audio which are change the mood of the baby, like this one. So this is the speaker is required. ESP32 is the processing unit where you can process this information. Camera is required to recognize the face expression of what they are happy, they are sad, like this one. Of course, a small size battery is required to run this system, and IMU sensor is required for detection the motion of the baby or motion of the walker, whether they are, that means they are moving or they are static, like this one. And all these things are in the device. The device is not a variable device, because this is the battery, and the science community also not support such type of devices, though they are the battery used as a variable of such type of babies which are or less than 2 years old. And that is not allowed right now. That means you need to take the permission if you are using such type of devices. So battery powered devices can use after a certain age as a variable device for the babies. To 2 years or less than 2 years babies is there, it is very risky or not safe for that one. So that's where whatever devices we have designed and set up on the walkers, not with the babies like this one. And so this is the example of how to use the ML and IoT for child care and other things. This is another way of how to use that means sensors, variable sensors, because this is a young person, they use the variable sensor for the classification of activity. Earlier we have seen that some approaches of the classification, the different from the earlier approach in this one is that here we use a one keyword early classification model. Early classification, this is a definition of early classification. There is one definition of early classification that says that you can classify the element before collecting the complete data set. So say for example, for the classification you need 100 accelerometer values. But suppose you have the 80 accelerometer values and you can classify. That is the example of the early classification. Of course, if you have the 100 data set, 100 elements, then you figure out and find out a good accuracy. If you have 80 data set, your accuracy is not as good as the 100. But sometimes what's happened that you need to generate the result in advance. And whatever the accuracy, loss accuracy or the wrong accuracy in this case, that is not much affected as compared to the delay in the data set, delay in the result. So we can take an example, say for example, fire detection or some gas leakage. So 80% accuracy, early fire detection says that some fire is there, generate the alarm. You start preparation accordingly. Your system triggering is there. Maybe possible there is no fire. Once you have the 100 data set samples in place of 80. That is 100 data set, you can take the correct decision. Early, you can, may or may not be your decision is correct. So if based on the 80, you can detect fire, you start preparation, doing all these activities. Once you have the 100 data set, if there's a fire, just start trigger of the system. So whatever from alert to the triggering is required, you can do during this early and your action is required. So that time is the early preparation is there. With the help of this, we can make the system more robust, more advanced. So say for example, baby sudden fall is there. If your sensor says that baby is moving the walker so fastly, or they are nearby stairs, or they are nearby some danger equipment, they generate some early warning sign. You can come and you can see, or you can start moving towards the baby room from the kitchen. So if you start moving towards the baby room from the kitchen, at the same time, the sensors or the camera capture the complete image and they say, no, baby is safe. By mistake, we generate the alarm. Not to worry, you start moving. But suppose that you are not start moving, and after once the complete image is there, once the complete information is there, then after they generate the alarm that baby sudden fall or baby is nearby the stairs, some sort of thing, then maybe possible even bigger loss is there, which will not be recovered at any cost. So that's where the early classification is the important part right now. And numbers of approaches comes into the picture. And people realize that do the early classification if you have the certain accuracy, if you have the good accuracy, and your result is very important. Suppose your water pump is there for the agriculture, not required early classification. If a water pump start after 30 seconds, doesn't matter is there. But if your car moving 100 km per hour in some expressway, so 60 minutes, 100 km, 1 minute you move 1.5 kilometer, 60 seconds you move 1.5 kilometer. Think about that, the importance of the 1 second or 2 seconds in that case. If your early classification generate that your tire, that is the overpressure is there before 1 second. That means indirectly you 150 meters or 200 meters early you can find out the result that your tire overpressure is there. You can slow down the car. After 1 second, after 2 seconds, your tire pressure data comes into the picture, entire data set comes into the picture, and your device says that no, the tire pressure is okay. There are some bumper is there because of that thing. The sensor detect the high tire pressure. So in that case, you can save a life and other things. So nothing to be worried. You just only start speed down of your vehicle. After 1-2 seconds, your sensor says that no, early classification because of early the sign was wrong, and we switch off that one. You can, but with the help of this, at least 200 meters before you generate the alarm and you generate and you can take the actions. So that's where early classification is very helpful. And luckily that very few work is there, so this is still an open problem. One of my PhD student, Dr. Ashish Gupta, they finished the PhD, and I can say that okay, this is the Dr. Ashish Gupta is the first student. They start working on early classification. You can see on the net that you find out one first survey paper on early classification that we have published in this direction, and after that multiple works comes into the picture. So I suggest that if any one of you start working on the machine learning, you can go through first classification and then after comes to the early classification in that case. Now this is another example scenario of machine learning in IoT. So assume that you are in active state. Your sensor node in active state, not your sensor node in active state. They monitor the environment, check that if something is happened. If nothing is happened, no one is going, no one is moving, I can go in the sleeping state. Okay, this is the life cycle of a sensor. Sensor initially, in very first sensor in active state, observe the behavior of the environment. If environment is nothing to be changed, no one is coming, no one is going, everything is going smoothly, they go on in sleeping state to save their power, to save their energy. After a certain time period, they comes into the active state. With the help of machine learning, we can find out the duration of the sleeping. Based on the past history, we know that okay, 1 p.m. to 2 p.m. is the lunch time in office. No need a surveillance camera and other things. Okay, like this type of way. Or based on the past history, we know that 2 to 3 p.m. power cut is not required because the people are not using much heavy machines at that time. Okay, so this is another example of machine learning in IoT. To find out the duration of the sleeping of this node, how much time we need to sleep this node, what is the duration of sleeping of this node, based on the past history, based on the action, what action they have taken in that case. This is another example of the machine learning in IoT. With the help of, we design one system, the system detect the gripping of the pencil, whether they are properly grip or they are not gripping properly the pencil. This is a proper grip, but this is not a proper gripping of the pencil. So if in an early stage when that one baby start gripping the pencil, not writing, character recognition is the different problem. When they are start schooling 5 years and so on, when the first time they grip the pencil and they start roughly anything wrong and right, whatever they want to write, they are start drawing rough drawing. At that time, it is very important to monitor their gripping skill, whether they are properly grip the pencil or they are not properly grip the pencil. If at the early stage, if we are not able to monitor the gripping activities and other things, later stage it is very tough to say that okay, you can grip properly like this one or that one. So this is the proper gripping, this is not a proper gripping, this is also not a proper gripping like this one. So IoT, they collect, so in the next slide, yes, there are some sensors are there on top of this pencil. They help to find out the angle, they help to find out the position of the gripping. They transmit this information to the server detect that yes, they are properly gripping the pencil or not. If they proper gripping the pencil, then that well and good. If not, then they generate the alarm, inform to their parents, inform to their teacher. They can guide them how to grip the pencil properly. So this is another example of the IoT. Here we design a node, and the top of the node, this one pressure sensor is there, so they can observe, they can monitor this one. This is another example of this machine learning in IoT. Then there some sensors are there inside the field. The sensors sense the field, such as moisture level, humidity level, water level, and other thing, And mobile sync is there. Mobile sync means that one base system, one processing unit, they can move here and there. They collect this information. This mobile sync is on top of the tractor or some agriculture vehicle, and they collect this information and transmit this information to the cloud for further processing. Cloud generate the result and generate the result, transmit to the end user. This is another example of the IoT, that how we can communicate this information to the end user. This is one use case scenario, recognize the gestures. So say for example, you want to switch on the TV. So traditionally we have the remote, we can press the button, we can increase the volume, we can increase the voice, we can decrease the volume and other thing. Gestures is a technique, they can act as per the user's demand. And how to perform the gesture with the help of voice, with the help of sensors like this one. So gestures increase the human experience, human behavior. That means they feel comfortable. You can just down the smartphone for decrease the volume. You can up the smartphone for increase the volume like this one. But here the IoT says that if we are depend only on the sensors, that is not a perfect way. Okay, that means in that case in the IoT, you need to use the two sources of the information. One is the voice, other one is the sensors. Then you figure out the correct accuracy. If you depend only on the voice, that is also not a correct way, because of the environmental noise and other thing comes into the picture. So you say the voice and the volume up. Maybe possible they are recognize your voice properly or not. If you do the both things together, that means volume up and also move your smartphone upward direction, then they can detect perfectly. So this example says that source of the multiple information is a good way for finding a good accuracy, and rather than depends only on one source of the information in that case. This is another example of use case scenario where we use the IoT and application, Ganga water pollution monitoring, because BHU is Ganga is here nearby the campus. So the Ganga water pollution monitoring, that we use some pollution sensors and dissolve oxygens and other things, and with the help of that one we monitor the water pollution level. We also monitor the level of the water, what is the level of the current water level, whether this is a danger zone or not, or suitable or not. So this is the Ganga water pollution monitoring, where you can use the machine learning and IoT. This is another example of agriculture land. You have some sensors, you observe the agriculture land and transmit this information to the base station. So you are not required the man-made effect for agriculture land monitoring and other things, that you can very easily monitor the lands and other things in that case. Here, this is a very interesting application of ML in IoT. So suppose you have the wallpaper in your mobile phone, and right now you want that means change your mood. That means you are the nervous, or you want to change nervous to the romantic mood. You can select this one, and based on the AI ML, they detect your moods and they change the wallpaper accordingly. Okay. So if you are very sad, you want to change your mood in the romantic, they automatically change the color of these images based on that one, and so that you feel comfortable. That is the way. And how they detect the mood? There is one very simple example, that you need to enter your, that means I'm very sad. Another is that when you are in sad, either you are not see the movies, or you write some text messages that I feel boring like this one. So based on that information, the smartphone detect your mood, and they try to change, they try to take the action based on that one. This is the final slide in that categories, that how to that they use the ML in IoT. One smart appliances or smart home is there. They have the multiple appliances are there. So power consumption is there. They show the power consumption. The IoT, they encrypt this information because they are not interested to share the raw information. They encrypt this information, they compress the information, and they transmit this compressed information to the base station to the end user. So the advantage is that you can observe that which appliance use more power consumption at your home. We have designed the system, deployed in the faculty quarters, and we find out the result is very interesting, and that is very useful solution. For awareness purpose, that don't run the washing machine every day. Once you have the sufficient cloth, then only you run the washing machine, because their power consumption is very high. And how you can detect? With the help of these type of systems where individual power consumption you can monitor in that case. This is the last one slide. That IoT and machine learning also helps your take care and health. So one very common problem comes into the picture recently, dementia problem, Alzheimer problem, that you are not able to remember or recall that what you are doing. So with the help of sensors, with the help of motion of your inside the home, you can easily detect that whether you have some health issues or not. If you are a normal person, you have no health issues, you are going source to destination perfectly directly. If you are moving, you forget something, once again you are going, you forget something, then you have some tense or some early sign of the Alzheimer like this one. So sensors can also helps to figure out that type of problems. So this is the last slide. So this is all about today. We cover that about IoT, about sensors, how to use these sensors, how to use these IoT applications. So in this talk, I try to cover the machine learning, I try to cover the IoT, and also some solutions that we are using at IIT BHU Varanasi and doing the research. So if any question, any queries, then please ask or...
So,
Yeah.
sir, I have a request to please share the slides and if possible the record video also, sir. Is it possible, sir?
I will share the slide. I don't know that whether this meeting is recording is going on or not, but I will share the slide definitely. You know? And if you have any query question, you can mail me. Definitely, you can mail. And if you want to visit, you can visit the campus also. And I will share the slides another. Still, if you have any query, definitely you can mail me. So we stop it here.
Your email address? Yes.
Yeah, you can very easily find, just write the Hari Prabhat Gupta and IIT BHU, so you can easily find mail ID.
Thank you, sir. Yes, sir. Thank you for your nice explanation, sir.
Thank you very much for participating in this. I will write my mail ID in the next message.
Yes.
Thank you very much to all the participants. Yeah. Yes. अच्छा ठीक
Yes,
है
sir. Yes.
ठीक है
Yes, sir. Thank you, sir. Yes, sir. And so one more thing, may I have a privilege to raise my concern here, sir? Actually, via this session, I want to request organizers, sirs, and respected madams. So actually, I am attending from the very beginning, like from sir November 18th. But sir, some sessions I missed in between. So again, I am continuing this, sir. So how long I have to continue, sir? As in the mail mentioned that 12-day session should be completely attended. I am attending still, sir, due to some missed session. I am continuing again this. Yes, sir. Yes. Yes, sir. Yes, sir. Yes, sir. Yes. ठीक है, sir. Thank you, sir. हाँ, sir. ठीक है, मैं एक्चुअली ज्यादा ही करूंगा क्योंकि मैं पूरा कंप्लीट ही कर लूंगा सर. अच्छा लग रहा है, बढ़िया सेशन. चलो ठीक है सर. ये उसके बाद सर्टिफिकेट का क्या क्राइटेरिया होगा सर?
Okay, sorry, I'm just interrupt. I'm out because I have the other meeting at 3 p.m. Thank you very much. Please, you continue and discuss on it.
Yes. सर सर्टिफिकेट का क्या कंडीशन होगा सर? कैन यू प्लीज से समथिंग हियर इफ पॉसिबल सर? मैं सर 20 में 3-4 डेज मिस किया था सर. ठीक है सर. सर्टिफिकेट कैसे मिलेगा सर? मतलब प्रोसेस कैसे होगा? नहीं सर, मेल में मिलेगा क्या सर? ओके सर. Thank you, sir. Thank you for your support and nice explanation, sir. And of course, as a Nice, and for me, rare FTP programs. So I'm happy to have this opportunity. I will continue till the end. So thank you so much.